So the first topic I wanted to discuss today is this issue of hierarchical metapopulation models. A lot of the students in my boot camp, which go into somewhat more detail than we've been able to this week, some of those students have been quite interested in metapopulation models that include representation in several populations, often with flow between those populations. So those populations might be farms, and you have flow of farm animals, or they might be cities, you have flow of people, or neighborhoods, or what have you, schools. This is a fairly common need, and often these are arranged in hierarchies of sorts. So we have regions, municipalities, neighborhoods, individuals, etc. And for those who stay abreast of the statistical literature, one of the advances within the past few decades that's most notable in health is the application of multi-level modeling, hierarchical linear modeling, models, and such techniques often seek to help an understanding of different levels of influence or association exerted by a hierarchy of contexts. So, for example, we may look at particular children and find variability in test scores and so on, and but we may be able to tease out that a lot of that variability is associated with general sort of variability between schools, and only then within it do we have sort of extra levels of variability between children. And similarly, there can be a higher level yet associated with variability between cities or counties or what have you. Now, hierarchical linear models and such statistical techniques are very useful for analyzing statistical signatures of these sort of hierarchies, but frequently they're associated with their own structural and dynamic complexities. So, for example, we may have dynamics associated with municipalities that goes beyond the dynamics associated with the neighborhoods within them, and also with the people within them. People may exhibit contact patterns that are largely limited to municipalities, etc., move between municipalities. Now, one of the reasons I'd like to give this lecture is not just the quite a lot of interest in hierarchies and their effects, and being able to make sense of hierarchical linear model, for example, results when comparing it to dynamic modeling outcomes. Although that's really substantial. Comparing the simulated results of these models, we can often then go and analyze them using hierarchical statistical techniques and see the degree to which they capture the patterns we see in empirical data. But there's another reason too, and it's to kind of get students out of the rut that they sometimes get in assuming a sort of script of building a model. So it's very easy with AnyLogic to use it in a way that doesn't exploit its full generality. It's very easy to use it in a way that, for example, falls into the habit of assuming that that populations can only live in Maine, that state charts are only used in people, and if one falls into that trap, one is often falling short of full tapping the power of AnyLogic, in the sense that often we get some of the greatest gains by using these things flexibly. And for example, here we're going to have populations of agents within other agents. And it just helps reinforce the point that you should be thinking creatively about ways these things can be composed. Don't just fall into sort of time-worn habits that you see in the example models. Push the limits. So I'd like to load in, for the sake of this example, the tried and true model we've been working with, minimalist network ABM model. And that's again provided as part of our example models. This is one to which we've kept on coming back. It's also one that we've built up ourselves. So, when it comes to sort of showing how to do these things from the ground up, we're just building on top of something that we did before. So if you want to build on top of something we did before, you could, but you may, my suggestion would be to go back to the sort of built-in model, minimalist network ABM model on the examples, and then I'd suggest saving it as hierarchical city population model, so that when we make modifications to it, you won't be stuck with those modifications from here on. Okay, so as we're speaking, I'm going to see if I can do the same here. So let's see. Here's movement towards mouse. I don't think we need that. I will close this guy, and I will load in the minimalist network ABM model. Okay, here we go. Just as a reminder, I'm going to build this model, and we'll just be reminded of sort of what's there. So this is our, excuse me, this is the SIR model. I didn't mean to do that one. I meant to do the minimalist network ABM model, which doesn't have SIR dynamics. Minimalist network ABM model, Sydney. No, I want minimalist network ABM model. Looks like I'll have to go open it explicitly. Okay, here we go. Minimalist network ABM model. Okay, so now I'm going to save this as hierarchical city population model. So save as hierarchical population. Oh, city population model. What did I say? City population model. Yes, not population city model. Okay. City population. Oop. Okay. There we go. Okay. So let's run this thing. Okay, I modified it. So we want to go back to main, and we want to set it to use a distance-based connection. Distance-based connection under environment, advanced. If yours exhibits this sort of ring, and I'm going to set it to be random layout type. So if yours was modified from before as mine was, I would just use that, and I'm going to call this Sydney, so we know it was made here. Okay, so all I did is I went to environment, and I set it to, under advanced properties, I set it to be distance-based connection and layout type random. That was the default, I think, although it said user defined. Oh, okay, and now we have we want to set the connection length to be, let's say, 50, something like that. Okay, connection range 50. Okay, well, that's good. Okay, and I think mine actually, I made the mistake of having this gain of partnership thing in there, so let me get rid of that. Okay, and I want to get rid of these things I accumulated. I'm sorry, I made the mistake of modifying this model. I just want to make sure it's in sync with everyone else's. Okay, there we go. So do you see something like that? Okay. Okay, so this is our baseline model. I just took a bit of time to get it back to baseline. Okay. So let's now build atop of this, and specifically, I'd like to build a model where main consists of a population of cities, and a city contains a population of persons. So we're going to have a two-level hierarchy. We're going to have the overall population, and then the city population, and then down to person. Okay. So we should have something like this right now. And what I'd like you to do is right-click. So I'm going to do something that will just save us a little bit of time, in the sense that we won't have to redefine that whole thing about drawing the get X, get Y for the displacement of the connections and so on. I just want to be able to reuse some mechanisms here that we built up earlier. So I'd like you to copy person and then paste it into the whole environment. So if you copy person, copy, boom, and then we paste it into the entire model name. We do paste, Here we go. So here's, now we should have person 1. Do people have that? Person 1? Okay. So all I did is, again, copy and then paste. Like that. You got that? Yeah, okay. So now what I'd like to do is to rename person 1 as city. Okay. So we're going to just reuse the kind of visual appearance we created for person and the fact that we have these lines stretched between them. We're going to rename it city. Okay. Here we go. City. So having done that, what I'd like you to do is to open main, okay? And I'd like you to actually, okay, so to be clear here, right now we have created a new agent called city. You notice it's an agent because you see the Da Vincian logo on it, right? If we go look in main, what do we have a population of in main? It's a population of what? Of persons. It's still a population of persons. We want it to be a population of cities, so that Maine will have have different cities within it, and each city will have people within it. Okay? Does that make sense? We want this hierarchy. So we're going to get rid of this population. Okay? Get rid of it. And we are going to then create a population of cities. So, pop quiz. How do I create a population of cities within Maine here? Sorry? Drag it in. We drag it in. This is one thing that I find some students get a little bit confused about, because in most cases when we add new elements to a model, we're dragging them from the palette, right? We drag in from that right-hand side palette, we drag in a time plot, or we drag in elements of a state chart, or we drag in stocks and flows, etc. Here, we're going to drag in, we're going to be creating a new population, and we have to drag in from the city. We have to indicate from what class we want to create a population. So we're going to drag that in, and I'd like you to name it cities, okay? So you can do that either when it first creates it, or you can go down and modify it here. So it's going to be called cities, okay? This set of cities which lies in Maine. So we just dragged in city here, and we've renamed it to cities. Does that make sense? Cities, okay. So we have a set of cities here, and we're going to set the environment for that city to be the environment. And I notice my model and notation here doesn't properly make note of this, but it needs to be set so that the environment is set to the environment. If you don't do that, it won't know to use the environment to take its cues as to where it's located. So I'm going to annotate these slides so that it's clearer. So we have cities, and then we have environment. Okay? So absent that reference to environment, it has no structure that's going to set its location. It's going to set the hierarchy, the linkage between them, the network context. In short, the spatial network context would be absent without that environment to knit them together. So we need to have environment set there for cities. Does that make sense? Okay. Okay, so we've set up the cities there. Now I'd like to go down to the environment, which is setting their context. And I'd like to make sure, okay, it's a distance-based network, but the connection range should be 250, okay? 250 rather than the current value that's used. So set that connection range to 250, okay? 250. What is that going to mean? If we upped it from 50 to 250, what does that mean? What does that connection range mean? More people over a longer distance. Two cities will be connected as long as they lie within 250 units or less space. Yeah. Okay. So we allow longer range connections, as was said. Yeah. Good. Okay. So now I'd like you to double click on cities. So we've just set up the high level structure of cities. Now I'd like you to double click on city in the project window. And what do we need to do to complete that next level down? What do we need to do to have persons living in cities? What do you think we're going to do? Drawing on your experience with AnyLogic, you're growing comfort with AnyLogic, hopefully. You're growing confidence with AnyLogic, hopefully. Yeah, we're going to create a population of people by dragging person into city, right? So let's open up city, and now we're going to drag person into city to create a population of people, right? And we're going to call this city population. You could have called it municipal population, but city population, okay? Right? Does that make sense? Within each city, there's a population of people. So we drag in person into city to create that population of people, right? Now suppose we want those people spatially arranged within each city, and suppose we want them connected together within each city according to connections. What do we have to do? What do we have to associate? With what do we have to associate this population? With a environment. We have to associate with an environment. So let us go at an environment. So for this, we take recourse to the palette, and it's up there in the General tab of the palette. We're going to drag in the environment there, and we'll call it city environment, okay? Now, way things work in Java, you could actually call this environment fine. It's not going to clash with the overall environment. There are different levels that live, as we say in computer science in our own geeky terminology, they live in different namespaces. They don't conflict with each other in any way. Rather than having a situation where the two Johns in the same house, it would be more like having, one John living in Canada, one in Australia. You don't have to worry that they'll get confused with each other. Okay, so here we have city environment, and we want to set it up so that person is associated with that city environment. Okay, so but first we'll set the properties of the environment, and we'll get back to that. So the properties of the environment here, we're going to set up a smaller range over which the environment is shown. So it's going to be a width of 75 and a height of 75. Okay, so that's under advanced in the city environment. We're going to set the width and height of that area in which people are going to be placed. And then we're going to set the network type to be scale-free. Okay, so we're going to have a scale-free network associated with people. There's going to be great heterogeneity within a city as to how many connections a given person has. Okay, so I'm on city environment. Inside of the city agent, I have this population. I have the city environment as a width and height of 75 under advanced for the environment, and a network type of small world. Who needs help here? Oh, sorry, scale free. Excuse me. I apologize. Yeah, thank you. So, anyone need help? Help? Okay. Okay, and now I'd like to go to the population and the city population and set it so that it references the city environment for its environment. So the city environment will take care of establishing the spatial position, the network connectivity of individuals. Does that make sense? Okay. And now we want it to be replicated. Okay. We want, what does this mean? I'm giving lots of pop quizzes this morning. What does replicated mean? It's the size of the city population. So replicated will mean there's many people within a given city, not just one, but many. And I think I said draw it from a uniform distribution between, say, 10 and 200, okay? So we're doing this right here. Uniform distribution between 10 and 200. So initial number of objects, uniform, 10 and 200. That's just the initial population. Of course, it could change after that. Births could occur, deaths could occur, migration, etc. But here we'll just set the initial population. So again, city population is replicated, the uniform 10 to 200, and don't forget to make sure the environment is set to be city environment, because the city population will need the city environment to set their location and set their connectivity. The topology of the geometry, who is connected to whom is connected, who is connected to whom, and the relative position within a city. Yes. Sorry? Oh, thank you. Did I say uniform? Thank you. Oh gosh. Thank you. Yes. Rookie mistake there on my part. Sorry. So sometimes it's hard to take off your statistician hat and put on your dynamic modeler hat, put on your software engineer hat. Okay, conceptually this is a uniform distribution, but it's a discrete uniform distribution. We have 10 or 11 or 12 or 13 or 14. And AnyLogic quite properly distinguishes between a uniform continuous distribution, where we could have real values. They're going to be rational, but real values, so double precision numbers between 10 and 200, versus one where it's discrete. You have only integer values. And so this is uniform underbar discrete. That's an underbar, not a dash. Maybe you call it something different here. Underscore. Underscore. Yes.
Sometimes you use underscore, and other times you use uniform and then capital
Yeah,
D.
yeah. So one is called camel case. There are two different ways of trying to make visually distinct the distinct words in a name, and one is called camel case, and I don't know if this has a name. It's underscore, underbar, separated names or what have you. It's a matter of aesthetics, and the Java community, in fact, encouraged by the creators of Java, originally Sun, now Oracle, having brought out Sun. They have style recommendations for how you name things, and because it's so darn important. For example, a method name should be first letter, lowercase, and then the suggestion is you use camel case for them. Package names are often written in this kind of form, all lowercase with underbars required. And so there's kind of stylistic guidelines for that. You can use either one, and I would say for your models, unless you're going to circulate them widely, you can, you're welcome to use your own convention that you feel most comfortable with, or that's easiest for you to see when you look at it. Just bear in mind that if you give your model to someone else, it may take them a while to kind of look at it. And so you could, if you were interested, check out what the guidelines are. They're pretty clear what the guidelines are. For example, all classes here, city and person, should be capitalized. And we do this because when we look in Java, and generally as software developers, when we look at a certain amount of code, or when we look at a computational artifact like a model, we want to just be able to glance at the name and know as quickly as possible what is that thing. What sort of thing is it? So that because we're often looking for certain types of things, we want to be able to just screen out a lot of things. And capitalization is one of the ways we kind of give hints as to that. So camel case is in Java much more common for the sort of where you capitalize the letter of each word. It's just vastly more common for naming variable names for naming, parameters for naming, names of methods for naming, names of classes, and all of those except for classes will typically start with a lowercase. But I don't want to worry people here about this. It's just that conventions are useful. It's often useful to have kind of a point of reference. And so here, this underbar is, here it's kind of useful in the sense that it helps capture the fact that this is a uniform distribution. It's just a discrete version of that. And so I actually think the aesthetics here are pretty good for communicating that. And it's just you can choose what convention you use, but I think it's good if you're going to do a bunch to try to look at what the conventions are and try to adhere to general graphic conventions. For example, things to return booleans, true or false, should be named is such and such, like, is male, is, lowercase, capital M-A-L-E. But if you, or you could have has connection, true or false. When we see that, we know immediately, okay, that's something that returns true or false. I just know it by looking at it, and that's often quite handy. So, long answer to a short question, and I apologize, but you can use both types of things. Question? Okay, so here's city environment. Here's initial number of objects, and we named this city environment. Okay, so I'd like you to run the model. Okay, so let's try running it, and okay. So we have just, looks like one. Oh, did I not? Okay. Okay. Thank you. So going back up to main. Thank you. I really appreciate that. Going back up to main. Let's go look at cities. And yes, I didn't replicate it. Thank you. So if we go up to main and we look at cities, initial number of objects. I should have probably had a slide in it. I just glossed over it. Pardon me, as I'm just, yes, it should be number of objects 10. I didn't highlight it in my slides here, and I should have. So this should be initial number of objects 10 for the number of cities. Okay. So apologies about that. What we got was what we asked for, which is 10 cities. That it wasn't what I meant to ask for, but that's one of the lessons of computers. You don't always get. You get what you asked for, not what you meant to ask for. Okay, so we have something like this. Right? So what do I see on the screen? Can anyone interpret for me what's going on in this cacophony of connections? Good. So maybe we'll make it just a little bit clearer. I have a challenge for you. Suppose I wanted to make the connections between cities red and leave the ones between people black. How would I do that? Where would I go? I make the connections between cities red. Okay, let's try going to main. Okay, we'll go down main and clicking on this. Where would I set this here? Anyone? Sorry? Okay, go to environment. I want those connections to be red. I don't see it here. It's actually not here. Where would it be? Where did we set sort of what those connections between cities look like? How come they're not a dotted line? How come they're not a really thick line? How come they're not a, some other sort of weird shape connecting cities? Where did we set the shape that connects cities? In city. It's in city. And where is it in city? Okay, good. So double click on city, and it's something to do with their presentation, right? Which are these things, if I wanted the connections between them to be in red. It's associated with this line. That's the one, right? So if we go and we go to, say, dynamic properties of that line, well, where would we set the color? Sorry. Of the city, yes. That's a graphic from the people. There's the graph. Okay, thank you. Thank you. Well, you're quite good. Much appreciated, Bjorn. You're dealing with as much jet lag as I am. So what just happened there? This is a very interesting point and actually a good lesson to learn. So I clicked on this, and I didn't catch it quick enough. What is this thing that I caught on there that I clicked on? Why are there two things? So if I click on this and I drag it out, why is there something under it? Visually, what's going on here? Parse it for me. We've got people within cities, and this guy here is actually showing the origin for where against which people will be displayed. What is this thing here? That's the connection between cities. So it's a little bit confusing. But it's especially confusing because we're using the same kind of shape here. So let's go here to connect this guy. So this guy is representing just the connection. AnyLogic happens to use that same depiction for person. In other words, whatever embedded thing is embedded in this population, it shows you a little picture of their presentation property so you can locate the origin against which that city population will be displayed. We actually want to put that back into place, but in the meantime, we want to change this. So if I wanted to change the color of this line, I can actually go up. I could do it through dynamic properties, so I could just go up here to general and change the color. Does that make sense, what I'm seeing here? I know it's a little bit confusing. That's just AnyLogic's convention for wanting to show against what coordinate system or what's the origin, it's the best way to put it, for the embedded population. And our presentation is actually under that, okay? This guy just happened to be sitting on top of it, and it was doubly confusing because it looks the same.
Can we change the circle for people within the city to make it clear that we want the same?
Yeah, why don't we do that? I like that idea, Roberto. So why don't we for this circle within city, let's make it what, a square? Something like that. Okay. The only trick is, do we have any property set on it? Like, is there anything dynamic? No, there's nothing dynamic set that we'd be, destroying brutally if we deleted it. So let's, ladies and gentlemen, let us delete it. Okay, this is a. I'm not aware of a way to enact shape changing. We could make it bigger for sure. Why don't we make it a square though? Just I actually, in previous presentations of this, I've made it bigger, but there's something that appeals to me about making it a square. Maybe that's because I am one. If you right click here, we can now do send to back. Boom. So all I did is I dragged in a rectangle, I put it there, and then I did send to back so I could see things that were in front of it. Does that make sense? And I'm going to make this, let's see, each of these is 5, so that's 25. I'm making it 75 wide, 75 down. Right? Okay. Now we have this representation for person that I'm going to move back into place. Why? Because I want them to be displayed relative to this place, to the right of this and down from that. Does that make sense? Now persons are going to be, like if a person is displaced within the city by 25, it will, and X and 0 and Y will appear here. If they're displaced 50 and X and 0 and Y, they'll be displaced here. If they're, 75 and both, they'll be down here. If they're 50 and X and 25 and Y, it'll be right around here. Does that make sense? People? Who needs help? Help? Sorry, help? Sorry, the city population, that looks good. Just right click on this guy and do send back. Maybe you already did that. Order. Yeah, and then send back. Yeah, that looks good. Oh, and the other thing was, did you color that big red there? Yeah, okay, good. So you could drag it back to place. That's all. Yeah? Okay. Okay. Very good. So can we run this thing? Okay. I'll take that as affirmative. Sorry, all the cities are in the same. All the cities. Oh, you're saying that the line goes to the top left hand. Is all on the top right of it. That's right. We could center it up like this, or we could place those around here if we wanted to. But I'm gonna leave it like that for now. Okay. So that's good. So we added in this municipal population. Do people see that? Is it okay? Okay. Okay. So we should see something like this. Okay, so I changed it here to a circle. Right. Okay, so we have that. Okay, so now I'd like you to. I motivated this little example model by a discussion of statistical techniques that are multi-level in nature, multi-level statistics. So suppose I wanted to create statistics at the level of a city, say on the size of the city. How would I do that? Can anyone tell me? How if I wanted to count the number of people in a given city? How would I do that? Yeah? Okay, go to the statistics for the city population. Excuse me. Here, this guy here. There we go. And I go to stats, and then do add stats. Are people clear about why I'm doing this with city population? Because I'm trying to decide the size of that city population. So for a given, in the city population definition, I want to do a count. And do you remember how this works? If I want to count the number of people that match some characteristic, what do I put in condition? I put a what? What sort of thing is in condition? It's sorry? Well, okay, it uses item dot, but it's what we call a predicate or a condition, a criteria that lies in that spot. It's something that's either true or false. If it's true, they get counted. If it's false, they don't get counted. So how if I just want to calculate the population? What do I put there? Okay, if we wanted to calculate something about the state chart, we could do that very readily. But here we want to calculate. Here we want to just calculate the number of people. Later, you're right. If we were to do a state chart, we could count the number that are in a certain place. Right? Okay. Does that make sense? So we're just counting true. In other words, every person gets counted. Yes. This is a good question. Let's test it. Okay, so first of all, let's build this. Okay, so it builds fine. How do we leave it blank? Complete successfully. Let's go look at the code. Control J, for those who feel up to it. Oh, it doesn't allow us to go there from there. Okay, that's well, we could put true, and then we can go see what the code is. So what would it appear if we didn't have it? I would think it would be blank, but it evidently tests it. So I'm guessing that it probably just correctly increments it. But let's go see if we could tease it into giving us something more. So I'll put a space there and do. No, it's not allowing. It's not allowing that. So okay, well, I could add another statistic and leave this one blank, and I could put true in this one, do Control J, and okay, here's the top one. It just increments it. So it does take it as true if we don't do it. Otherwise, with true, it puts this in here. So the answer to the gentleman's question is yes. It does do it properly with a blank. However, I consider that puzzling. I don't know what that means looking at that, so I like to have true, and then it's clear what this means. Every person is counted is what this means. Does that make sense? So neat hack, though. Okay. Okay, so let's run it. Okay, so let's run the model. Okay, folks, now suppose we wanted to see what that population was for every city. How would we do that? How would we figure out what it is for every city? The population. Precisely. Okay, and this is what I'm getting at. Let's go click here. Oh, what do we see there? Parse for me what's going on here. What is that thing? Okay. We have 10 cities, and then why do you have sort of a diagonal sort of thing here? What does this mean that this is sort of to the right of that and below it? What does this mean? It's inside of it. So the cities are inside of Maine, and the city population for a given city is inside here. So we could go to a given city, for example, and here's information about its population. Here's city 1, city 2, city 3. Now, how if we wanted to see the stat? Well, we could always create a little graph or a table, but actually we could just click on this and we'll see the statistics here. This is one of the nice features of statistics, and this is automatically updated as the model runs, in fact. So if it were changing, it will be updated. City population stat is a very useful way to sort of, if you define statistics, you can use them interactively to collect information about what's going on. You can interrogate what's going on through the use of statistics by including those in a population. Does that make sense? So the city population stat. So this is 22 people. If we go up to the next city, we have 12. This is 28, 29, etc. And you'll notice that accords with this statistics on 13 active objects. So your statistics are available here within your within the associated population, and they can be interrogated in this sort of way. We can, in fact, take a copy of this if we so wanted, etc. Okay, so that's pretty nifty. We could, of course, have state charts associated with a city, for example, whether it's solvent or not, or the nature of its the evolution of its city government or something like that. Okay, so now suppose we wanted to have people have incomes here and have those incomes distributed over according to some normal distribution. How would we have people have incomes here? Okay, it would have to be in person because it's a person level attribute, right? Okay, so let's go down to person. And what do we have to do to give them an income? Suppose it's we just want to represent it for now as a static quantity. How do we give them an income? We'd add a what to them? A parameter. We could do it with a variable, but suppose we want to say up front, we want to be able to have the enclosing population tell the person what their income is. And then we use it as a parameter. Because, ladies and gentlemen, and this is one of the pieces of my normal boot camp that I've downplayed here. We have variables and populations. One of the things I emphasized earlier about the difference is that variables are typically used for quantities that change over time. Parameters are typically used for quantities that change less in time, but more importantly, arguably, they're used to communicate assumptions. So, and I want everyone to pay attention to this statement. This is a statement with import. If you have a parameter for a given component of the model, the assumptions about the value of that parameter are set at the point where that component is created. Okay? So, if you have a person here with an income, where would the properties of that income, the value associated with that income, be specified? Riddle me that. Well, let's go at it, and then we'll sort of follow through it, make it an operational question. So here we have person. And now, ladies and gentlemen, I'd like you to drag in parameter into person, and we'll call it income. And what sort of thing is this? Is this a Boolean? Is this a string? Is it a date? Is it a color? It's a double. It's a double precision value. Conceptually, it's a real value. Let's give me an approximation there too. It's a double precision value, so we'll leave it as that. Okay, so now where do we specify what income someone has? For a given person, where will that be specified? Well, okay, default value, we could fill something in there, but that will just be if the place that creates this, and I'm leaving that mysterious for the moment until you figure it out. If the place that creates this doesn't specify a value, this one will be used. So we can specify an expression there, but that actually doesn't automatically set the initial. That's not the initial value. That's just the value of the place that creates it, be it a call or some other important place. If it doesn't set it, it'll use the default value. But where would the, ladies and gentlemen, where would the value be set? It's set in the population. Okay, and what population here sets it? The city population. So we're going to go up to the city, and we go to general here, or parameters, better yet. And here's income. Here's income, right? Okay, so what I'd like you to do is to, okay, so I'd like you to go associate. I thought I had some slides on this component, but instead this is some slightly more advanced stuff. So I'm going to have city population, and what we're going to do is first suppose we want to have an income that's log normally distributed, log normal with sigma equal to 4, log mean equal to 4, and log standard deviation equal to 6. Okay. What does this mean? I'm deliberately rehearsing things here, folks, because I want to drive home points made earlier in this boot camp. I know this is a certain amount of repetition, but it's artful repetition. It's designed to be artful repetition here. What does it mean that I put this formula here? Does it mean that everyone is going to get the same value for their income? Right, and so for each successive person, it's going to be reevaluating this formula. And it's going to get a new value for it for each person. Incidentally, you notice, as I said earlier, you actually have information about for whom you're getting it here by their index. Or it's this person 0, 1, 2, 3. So you could have the income going up, the number of the person goes up in the population. Here we're just going to have it be randomly drawn. Okay, so this is great. Let's run this. Okay. Okay, so run. Oh, we have to specify minimum. Sorry. Actually, this is a point against which the x position is measured, but it should be 460. it's the last parameter of it is a minimum. Okay, so if we run this, now we can go down. So if we want to browse people's income, how do we do that? Sorry? Okay, we could do a trace LM, but I could do it interactively. If I want to look at the income of different people in the population, how could I do this through the interface? Sorry? Exactly. Go down to this level of an agent. Here, this person's income is modest, indeed, but there's great variability. Yeah, some people have very large incomes. Some people have quite low incomes. Okay. So that's good. But now, ladies and gentlemen, suppose we want to compute for a city the mean income in that city. How do we do that? Sorry? Okay. So we will be putting something in main eventually, but if we want to compute the mean income within a city, because remember what Maine had is several cities in it. So if we want to compute the mean income within a city, where would we go? City. So we'll go to city. That's right. So let's go to city. We're going to go to the city population. Well, okay, so where do we put it within city? And where do we put the, so if we wanted to compute the mean of the populations across a given city, where do we put it? In city population. It's a statistic on the city population. That's right. So, so we go to city population, and we put a what there? A statistic. This may seem trivial, but people find it difficult to know where to put things in these models. And I find it helpful for students to be exposed a couple times to sort of where things live. That's one of the reasons I'm doing this. So you got to go to statistics. And what are we going to do? We're going to add a statistic, and I'm going to call it, mean income. And what do I do? Tell me what to do now. Sorry? Average. And what do I put in for average? Well, this is going to be so this condition is just like that condition. So what's that going to be? I want an average over all people in the city. Therefore, this condition is true. And what am I going to average over? So this expression, if you would go to look at this, it says item. Item represents the embedded object. So it's going to give us a variable called item for each successive person. Items for the 0th person is going to be given to us. We'll have to give it, it'll evaluate an expression to get their income. Then for the first person, it gives us a reference to the appropriate person in item. And it's going to evaluate it and get the income for that person. And then the next, and the next, and the next. So what formula am I going to put down for the expression there? Item.income. That's exactly right. Item.income. Does that make sense to people? So item is a reference to a person, and we're saying, hey, what's your income? Now, we could also have a function that returns their income if we preferred to do it that way, which would actually be more general. That would allow us to maybe have a state chart for income, and then just return a value from that. Or we could have a parameter sort or what have you. We could have it change it over time. We would be insulated from change at the level of the individual by having a function call here. But I'm doing it in a way that it tries to be simple here. From a software engineering perspective, it would be much better to have a function call because it would insulate us from change at the level of person. But we're doing item.income. Does that make sense to people? The fact we're doing item.income here. Does that make sense? Okay. So let's go look at the mean income here. Okay, so where do I look to find the mean income for a city? Where do I look? Sorry? In cities. And where do I go? Sorry? Yeah, right here. And here's the mean income of 137,000 for this city, 270,000 for this, 1.12 million for this one, 35 million for that one. mean income, right? Maybe that's Beverly Hills or something. So we've just set the mean income for the cities. Does this make sense? Okay. We are going to now take what I'd like to do now is to have a, yeah, this would be interesting. Suppose I want to do a mean across cities. So I want to take mean across cities, treating a city as you know, all the cities equally weighted. So how would I do that? So I want to have a mean income sort of, or I want to say I want to compute the max and the minimum city incomes. Where would I do that? I want to, so we have so each city has a mean income, a mean of an average income across the people in the city. Suppose I want to now get information, what's the maximum mean city income and the minimum mean city income? Where would I do that? What's this city? To cities, like the cities within Maine. Yeah. Okay, so we're going to go up to Maine. We'll go down Maine. And here's cities. And so where do I put it? Statistics. Add statistic. And I'll do min average city average income, something like that. Right? So tell me what to write. What do I choose for the type? Min. And what's the condition going to be? True, because I'm doing it over all cities. What's the expression going to be? We actually did this before. I'm trying to rub this in. Not in a painful sense. So that's probably a poorly chosen phrase. I'm trying to reinforce this point, not rub it in. I'm trying to reinforce this point. So what expression would I use here? So how do I know the name of a city? Item. It's the name of the embedded object. Here it's a city, right? Okay. Now, suppose I want to ask what that item's mean population is. Or, sorry, mean income. What do I do? Okay. There's a lot of good ideas going around, but I would tell you, may I remind you, that statistics are turned into what? They're turned into, remember where we created a graph yesterday, which graphed out a statistic over time? Do people remember that? What did that do to get the value of that statistic? They're turned into methods. They're turned into a method. So how do I get the results of that method here? Sorry? I call it. So item dot, this is a bug in AnyLogic. Oh, sorry. It's Andre, you probably are aware of that, where it says package only. Yeah. Yeah, exactly. Mean income. You just go like that. I mean, it's a very minor thing, but occasionally it. So, okay, it's unhappy. I thought it was called mean income at the city level. What did we call it? I thought we called it mean income, but hold on there for a second. Let's look under city population. We called it mean income. Look at that. Okay, so it says it's undefined. That's a mighty interesting thing. Why is it saying it's undefined? Let me do this. No? Okay, mean income is undefined for type city. Well, I'll... it's not helping much with the auto-completion. That's the problem. Okay, it should be able to do that. So I'm surprised. Give me a second here. Let me go come into another context. Pardon me. I'm just gonna go put some code elsewhere to see. Okay, so city c dot mean. No. Okay. What are the things I can do with a c? Okay. It doesn't seem to know about mean income. That is the. Is it? Maybe it's because I didn't compile it yet. So let me try that. Thank you very much. I appreciate that information, Robin. Mean, no? Okay. Okay, well, city C, of course. Of course. Sorry, folks, I was being silly here. It's true the autocompletion was not working, but we should be fine. So cities here, this statistic, it should actually be city population dot mean income, and that's why it's a method on the population within city. It's not on city as a whole. All right. So here, this is the statistics that's defined on the population within city. So within city, we have a city population, and so here we're simply taking the minimum across the mean incomes associated with the population. So each successive city, it'll get the city population associated with that city and compute the mean income. Does that make sense? Okay, so I'm going to copy this to the big screen in case people can't see this. After all, we're near Beverly Hills. So there we go. Item.citypopulation.mean income. That's what's in this expression. So to be clear, it's evaluating this expression for each successive city in turn. So for a given city, as a reference set, it's getting its population, and then it's taking the mean income current by calling this method on that population, on that city population. And it's doing this for each city in turn, and then it's taking the what of these? The minimum. Okay, so now suppose, folks, that I want to calculate the maximum. Tell me what to do. So I want this to be max. Okay, I added statistics, and then do what differs between the two? I do max, and everything else is the same. Because we're taking the max over the same thing, right? Okay? Does that make sense? Does that make sense to people? No? Okay. Good. So let's run this thing. Okay, here we go. So here we have these different cities. In a given city, we can go see, as before, its mean income. And then we can go up to all cities, and we could see the minimum city income and the maximum city income. Do you see that? The minimum city average income is $8,000, and the maximum is $35 million, something like that. I mean, it'll differ for each person's because of the component. So where am I going? I went to main, and I went to cities, and this specifies the max and the min, right? Does that make sense? Are people okay with that? Okay, so now I'd like you to go and we're going to impose a, so we really haven't taken advantage of this whole issue of sort of differences between cities in terms of means. This whole idea that hierarchical, multi-level statistics try to draw out. And so, ladies and gentlemen, suppose we wanted each city to have a, so right now we're taking for each person in a given city, how is their population being determined? If I wanted to find in this model where a given person's income is being determined, where would I go? Think about a person. Where is their income being determined? It's in a parameter. So what does that tell you about where it's determined? Run and drive this point home. Determined at the city level, and in what particular construct within city? So here's city. Where is their income determined? For a given construct, it's in city population. So it's very good, very good. I appreciate that. So I want to drive home this point again. When you have a given component that has a parameter, that parameter is a conduit for communication of assumptions to that element. The value of that parameter is going to be set, typically maintained for some period of time. It's going to be set at the point where that component is created. So for a person, where are they created in this model? In the city population in particular. For a city, where is it created? In Maine. Maine, where is it created? In the experiment. The experiment that creates Maine. Remember that when you call up an experiment, it has that screen with a button? You got to push that button, it goes and creates Maine. And I'm going to link this in with things later this morning. But in a parameter variation experiment, in a calibration experiment, they're going to be creating one Maine called root. Creates it, runs the model, gets rid of it. Creates another one, runs it, gets rid of it. But I'm actually hiding some things. It actually creates it, runs it, extracts some information from it, extracts it out of it, gets rid of it. The next one it runs, extracts some information, and then throws it away. Not the information, throws away that Maine. Creates another one, runs it, sucks the information out, throws it away. So each successive one, it's extracting information from, creating them, destroying them. They're creating Maine. Maine is a transient object from the point of view of an experiment. Parameter variation experiment will run many simulations. Maine will come into existence, run, get rid of it. If you have multiple processors, so sometimes you have several Maines running at the same time, one in each process, one in each core. And then we'll get rid of them. Okay, so parameters, ladies and gentlemen, one of the more important points. Parameters are given their values at the point of creation. For a person, city. For a city, Maine. For a Maine, at the experiment. That's where those are defined. They're conduits of communication of information about assumptions. A point of significance. Okay, so here, suppose we want, I've said, right now, persons' assumptions about their income are set at the city level. Do those assumptions about the log mean and log standard deviation, not log normal, are those different between cities now? No, they're not different between cities. Let's suppose we want them to be. So we want some cities that are more like, well, I don't have a good example from Australia, more like Hoboken in the US, and some cities that are more like Beverly Hills. And so we want to impose some heterogeneity at the city level. So where would we do that? How do we have heterogeneity at the city level? Have different cities have different log means and different log standard deviations. Where do we do that? How do we impose heterogeneity? How did we impose heterogeneity at the person level before? In a parameter. So if we want to impose heterogeneity for a city, what are we going to use? A parameter of city, right? Okay, so let's go to city, open up city. Let's drag in a parameter to it, and let's have this be log mean. So log mean income, call it. Is this an int? Is it a Boolean? Is it a color? Is it a date? Is it a string? What is it? It's a double. Let's drag in another parameter. Let's call it log standard deviation of income. Okay. Okay. Log mean of income, log standard deviation of income. You got that? This is in city. We want each city to have a different distribution characteristic. Does that make sense? So we're going to have heterogeneity at the city level that is imposed. So the different cities have different economic positioning. Some are nearer to natural resources. Others have a great harbor that can be used for shipping. And that's going to dictate sort of characteristic income and standard and distributions associated with them. Okay? So now suppose we want the city population to have a distribution of incomes that are set by this log mean income and log mean standard deviation. In other words, suppose we want people in that city population to have an income that's drawn from a distribution where the characteristics of that distribution are, it's log normally distributed, but with this log mean and this log standard deviation. Where would I go put that? Where are the incomes of the members of the population set for a city? It's in city population. It's in city population. Okay, and where in city population? Where do I go? Okay, and what tab here? Parameters, yeah. Okay, so now we have this log normal. Tell me what to put there. What's the first one? Well, log standard deviation. How would we know? Well, you can do control space, and here's, oh my gosh. That's the one I expected. I think that may be an inconsistency in help. Oh my gosh. Okay. Let's go take a look at this. I just want to go which is which. According to that, mu is first and sigma is later. But I thought we checked yesterday in the help here, log normal. Oh, for normal. Oh, I see. Okay, so for normal, it's reversed. Maybe more like snafu. Okay, that would be good to be able to resolve. Okay, so log mean is first, log mean of income, and then log standard deviation of income, right? Does this make sense? We're imposing. Now each person is going to be drawn from a distribution. His characteristics are given by those parameters for the city. Does that make sense to you? Okay. And then tell me, who's going to set the values of these parameters for each city? Who's responsible for setting the parameters for the city? The Maine. In what part of Maine? What is going to set the parameters for each member of cities? Cities, and the parameters there, right? And suppose we want a log mean income that that's uniform between 4 and 7, and a log standard deviation that's between 2 and 4, or something like that. Uniform, because these are double values that could be 3.5 or they could be 4.2 or whatever. Does that make sense? Does that make sense? Okay, so to recap here, we have cities. Each of them is associated with sort of a characteristic distribution as specified by a log mean and log standard deviation. The population within that city is distributed accordingly, drawn from a log normal distribution, and then those log mean and log standard deviation of each city is set by Maine. So that captures kind of the city varying characteristics. Does that make sense? Should we run it? Okay. So here we go. We go down to city. Here we have a log mean, log standard deviation. Here we have a log mean, log standard deviation accordingly. And let's look. Here's a city with a log mean of 6. If we go down and we look at the people within that particular city, we'll find that, you know, they have a variety of incomes, but we can go up to the city level and get the mean income is 6,821. By contrast, here's a city with a log mean of 4, and here the mean income is 750. This is useful. Now you may ask, well, why impose things? Because I'm capturing a structural feature of the cities there. I'm capturing differences between cities. And if new people are born in the city, they'll be drawn from the appropriate distributions. Or they can be drawn from the appropriate distributions. If we wanted that, it's good practice for, say, at the city level, and I'll let you go in just a second here. At the city level, you'll notice these parameters. We've been kind of sloppy about setting a default value, but we could put an expression in here. But more importantly, it's at the person level because persons are coming and going. So for a person's income, we might put in an expression here that gives a sort of default distribution. Okay. Okay. I think that's all we have time for here with these hierarchical models. You will find lots of additional slides on having infection propagate between cities, adding names to cities, for example, and even a situation where people move between cities. Okay, and you're welcome to look at these slides for that. You'll find quite a bit of work going on. Personally, as someone who does a lot of health modeling, I find this capacity to create hierarchical models quite helpful. I work in a lot of nested contexts. Maybe we have hospital, ward, and then people. And being able to keep track of statistics, being able to even just sort of understand visually what's going on and explore, it's often quite helpful. There's a few minor things that are a little bit awkward, particularly in moving people between cities. There's a slight bit of awkwardness with that, but overall it's a very, very viable strategy. And it's a testament to AnyLogic that allows you to put forms together like this. To be very clear, this can be extended to an arbitrary number of levels. You could have cities, neighborhoods, schools, children if you wanted to. And you could compute statistics, and in each case it's quite convenient because the structure of that hierarchy, people here within cities, cities within global environment, it mirrors the situation in the external world. And we can sort of reason about different subcomponents of the model as we do about subcomponents of the external world compared to statistics, particularly comparable subpopulations, etc. Okay, so that's all we have time for hierarchical model. We now have a break, and we'll regroup in another 15 or so minutes. Very good.